So now I am going to continue with my next part. So that is in the previous class we discussed about the basic things regarding to that creating an architecture one according to functionalities and architecture and system quality attributes and quality attribute scenarios and all. Okay, now we are going to learn about the quality attributes. Okay, so we are having the 6 types of quality attributes. Okay, those are availability quality attributes, modifiability, usability, testability and all. Okay, so we are going to learn each and every one individually. So that is the first one, availability scenario, as I said in the previous. So availability is considered with the system failures and it is associated consequences. Failures are usually a result of system errors that are derived from faults in the system. It is typically defined as, how to define it, alpha is equal to mean time to failure by mean time to failure plus mean time to repair. Okay, now we want to make system ability, we need to also follow the quality attribute scenarios. Those are 6 parts. So according to here also we are having first one, source of stimulus. Okay, now we differentiate between internal and external indications of failures or failures, since the desired system response may be different. In our example, the unexpected messages arrives from outside of the system. Okay, so that is, so how there are internal or external indicators. Okay, so of failures or failures since desired the system response may be different. Okay, so those are those failures will be comes from outsides. Okay, unexpected message from the by unexpected messages arrives to the particular system. Next, stimulus. A fault of one of the following class occurs: omission. Okay, that is sometimes the false will be occurs. Okay, according to omission, and a component fails to respond to the an input. Okay, sometimes the components will be failed. They can recognize the particular input, that is called crash. Okay, so the component repeatedly suffers omission fault. Sometimes the components or elements repeatedly suffers. Okay, that is the omission fault. That is timing. Okay, frequently, that is called timely. Okay, that is timing. A component responds, but the response is earlier or late. But sometimes the components or elements will be respond. Sometimes they can respond earlierly, sometimes they are late. That is called response, the response time. The component responds within a incorrect value. Sometimes they can give the incorrect value, missing values. Okay, those type of problems will be occurred. Okay, some types of faults, some types of omissions, sometimes it will be crash, sometimes that it will be gives the false results according to timingly, sometimes it will be respond fastly or lately. Okay, these are different types of problems will be occurred. Then this is the general scenario for availability attribute. Okay, now here either the event is an internal or external source. Okay, an internal or external source. Okay, then they can get some stimuluses. Okay, those are either false, either omission, either crash, either timing, either response. Okay, now how they will get this type of problems. Okay, then what will be happen to the environment? Sometimes it will be normal me, sometimes it will be degrabbed, sorry, sometimes it will be operate normally. Okay, now these can be processed on storage, and then sometimes it will be communicate. Based on that we can get the response, either it will be recorded, either it will be notified, sometimes it will be disabled, sometimes it will be continue, sometimes it will be normal, sometimes it will be unavailable. These can be occurly timingly. Okay, now frequently they can occur. Next, response measure. Okay, now what is the response measure? Some problems will be occurred, we need to repair. Timely, availability, available or degraded, time intervals. Okay, now these things we need to make together. Okay, either the event is a internal or external, so they can get some stimuluses, some problems, so the environment can be react according to that. Sometimes it will be process, sometimes it will be storage. Okay, sometimes it will be communicate, sometimes it will be degraded, sometimes it will be normal. But the response is sometimes it is recorded, it's notified, it disable, it's continue, sometimes it will be unavailable. Okay, now the resource measure is nothing but the repair will be make into the consideration. Timely, availability. Okay, we can focus them to frequent scenarios, the functionality will be good, that is called availability. Artifact. Okay, now this specifies the resource that is required to be highly available. Okay, and that is artifacts such as processor, communication channel, process or storage. Next, environment. The state of the system. Environment is says what? The state of the system. As I said in the previous, it is busy, it is running, is runnable, the overhead, helmet, whatever it may be. The state of this, it says the state of the system. Okay, now when the fault or failures occurs, may also affect the desired system response. Okay, now so sometimes the faults or failures will be occurred. Sometimes they can be affected. Okay, now as next, for example, if the system has already seen some faults, already the system having or seeing some faults and is operating in other than normal mode. As a normal functioning kakunda, it can be operating in normal. Either it is a blood, whatever it may be, it's having some disturbances and all. What next? It may be desirable to shut it down totally. Okay, now however, if this is the first fault observed, some degradation of response time or function may be performed. Okay, now in our example, the system is operating normally. Then response. There are a number of possible relations to a system failures. Okay, different types of causes are there to fail a system. These include logging the failure, notifying selected users or other systems, switching to a degraded mode with other less capacity or less function, shutting down external systems or becoming unavailable during repair. In our example, the system should notify the operator of the unexpected message and continue to operate normally. So that is the response. Response measure. The response measure can specify an availability percentage. So how much time it is available, it says the percentage of that availability, or it can specify a time to repair, and also it can specify how much time it will be resolve the particular problem. Time during with the system must be available within the particular time, whatever it will be shows to specify in that time it will be must be repairable and available, or the duration for which the system must be available. In the particular duration, whatever the duration it will shows, the system will be repaired and it will be available to reuse. Okay, now these are the response, that is called availability. Next, modifiability scenario. Okay, now modifiability is about the cost of change. Cost, mainly it can focus on the cost of change. It brings up two concerns. Is mainly it brings with two concerns. What is that? What can change? The artifact. So that is what can change, what we need to change, what we need to modify. Then when is the change made and who makes it? The environment. Okay, now what can change? What is that? Artifact is a particular environment, is a part of the environment or entire the environment. That is artifact. Next, when is the change? Eppudu we need to make the change, and who makes it? When and who makes it? That is environment. Okay, now that is modifiability scenario. It's mainly focusing on cost of change. Once we have once the architecture created, when we want to change something, it's related to the cost. Okay, next, this is the architecture regarding to the particular scenario, modifiability scenario. Here the source is user. Here the source is users. So they can have some stimuluses, that is initiate and transactions. So they can initiate some transactions. That is a system. Artifact is a system. Then the environment is under, is a normal, is operations. Then response, transactions are processed. Response means what? The whatever the transactions is sent by the particular users, the artifact will react on it, then it can be taken to the environment, then it can be processed. That is called response. Transactions are respond. After we will get the results. Okay, now that is how much percentage with the average with latency of 2 seconds. Okay, now average time or latency of 2 seconds. So how much time it can be give the response, that is response measure. So these are the 6 parts of the particular mod attribute scenario. Next, according to Ken, source of stimulus. So what is that? The portion specifies who makes the changes. What we said in the major 2 points, who makes the changes when? That's the thing. It is developer. But who's that? Who makes the changes? Users. Who's a user? Is a developer. Okay, now a system administrator is a developer. Maybe he is a system administrator or is a end user. That's why here the entity is a users. The users may be a developer, is a system administrator or an end user. Who using the system currently? Those persons are called end users. Okay, now so and clearly there must be machinery in place to allow the system administrator or end user to modify a system, but this is can common occurrences. Next, modifications is to be made by the developers in general. The stimulus, the portion specifies the changes to be made. Definitely the changes to be made. A change can be the addition of the a function. So what is the change? It is we can update. Change means what? We can update. Update means what? We can add, we can delete. So whatever it may be, we can update something to the existing without missing the actual. Okay, and that is. So the modification of these existing function or the deletion of a function. Okay, and that is we want existing function we need to modify, or sometimes we need to delete. It can also be made to the qualities of a system, making it more response, increasing its availability and so forth. So what is the main modifiability? We can change something. Why we can change something? It's making more responsive and increasing the much availability. That's why we can change something where required. The capacity of the system may also change automatically when the availability is increased. The capacity of the system is also be increased. It's also be changed. That is the major thing. Next, the stimulus is a request to make modification, which can be the function or capacity. It is a stimulus, generally what? It is a request. It's an acknowledgement. We can some message to make something. Okay, na? So it may be, which may be the function, is be a quality, is a capacity. That stimulus is shows this one. Next, artifact. The portion specifies so what is to be changed. Okay, na? When, who changed, and what we need to change. That is mainly focusing the artifact is a system. The functionality of a system, its platform, environment, it's a platform, its user interface, its environment, or another system with which it interoperates. Okay, that is called artifact. The modification is to the user interface. Next, environment. So this portion specifies when the changes can be made. So environment, when the changes can be made. Design time, at compile time, at build time, at initiation time or run time. So when we need to change, who will be changed, what we need to change. So which portion we need to change. So that is the environment. This portion specifies when the change can be made. In which situation? Either in the design time, either in the compilation time, either in the build time, or either in the initiation time or run time. So in our example, the modification is occurred at designer time, at design time. So we can, once the architecture is created, it is difficult to change, as I said previous. So when we can make the designing, it's easy to change something. Okay, na? That is, it will be mainly occur at design time. Response. Whenever make the change, after making the change, so either design time or either compilation, whatever it may be, mostly in the design time. So whenever makes a change, must understand how to make it and then make it, test it and deploy it. Okay, na? Where it change, we can understand it, then make it, test it and deploy it. So in our example, the modification is made with no side effects. Definitely it's made with no side effects. Next, response measure. All of the possible responses take time and cost money, and so time and cost are the most desirable measures. So in this creating an architecture, the most desirable measures are time and cost, time to market, and also cost is very effective. Okay, now so that is time and cost are the most desirable measures. The time is not always possible to predict. Yes, it's a thing, we can't predict the time always. However, and so less ideal measures are frequently used, such as the extent of the change. Sometimes we can extend the time, number of modules affected. In our example, the time to perform the modification should be less than 3 hours. Okay, that is, this is the modifiability scenario. Next one, performance scenarios. Third one, performance scenarios. Performance is about timing. Okay, now it's mainly about timing. Modifiability is mainly about cost. It's mainly about timing. Okay, now events. Okay, now timing, that is mainly events. Interrupts. What are the events? So interrupts, messages, requests from users, or the passage of time. Okay, now these are the events. It's mainly depends upon timing. So the performance is about what? Mainly it on timing. Okay, occurs. Events occurs. The system must respond to them. So whatever the events will be occurred, the system is must be respond to the particular events. Either it is a interrupts, either it is a messages, either it is a request from the users, whatever it may be. So the system can be respond to the particular events. There are a variety of characteristics of events arrival and the response, but basically performance is concerned with how long it makes the system to respond when an event occurs. Okay, that is called performance scenario. Next, this is the architectural scenario for performance. That is here the source is developer, so he can make some stimulus, some requests, wishes to change the UI, user interface. Okay, na? That is artifact, that is the code, environment at design time. When it at design time we can. So measures modification is made with no side effects. We want to make some modifications with no side effects. Resource measures in 3 hours. How much time it will be respond? Within 3 hours. Okay, now the source of stimulus. The stimulus arrives either from external or internal sources. In our example, the source of stimulus is a collection of users. Okay, here stimulus. A stimulus are the event arrivals. Whatever the event already I told. Events arrival. The arrival pattern can be characterized as periodic and stochastic, okay na, or sporadic. Okay, in our example, the stimulus is the stochastic initiation of 1,000 transactions per minute. Okay, na? So 1,000 transactions per minute it can be processed. Artifact. The artifact is always the system services as it in our example. So always the system services. This is called artifact according to this performance. Environment. The system can be in various operation modes such as normal or emergency or overhead. In our example, the system is in normal mode. Okay, and that is environment. Okay, now, so next response. So the system is gives a response to the users. The system must be processed at arriving events. So, but when it will respond for whom? So what are the events is occur to that? It will be respond to the particular events. Okay, so this may occurs a change in the system environment. For example, from normal to overload mode. Okay, in our example, the transactions are processed. Response measure. The response measure are the time to take to process the arriving events, latency or a deadline by which the event must be processed. So the variation in this time, jitter. The variation of the time is called jitter. The number of events that can be processed within a particular time interval is called as throughput. So how much process we can process within a particular period of time is called throughput generally. So that is what the number of events that can be